Hello again in another video about Proxmox. This time I want to show you my way of installing Prometheus and Grafana to monitor a VM or CTE container in Proxmox. We can use that for VMs, we can use that for LXC containers, doesn't matter. I'm going to use LXC containers because is like lightweight and installation is smoother. In VM, I have to install like operating system on VM. That's gonna take time as a mission a little bit. Not a problem. I can do that off camera, but I want to show you how to do that with container this moment. So we're installing Prometheus and Grafana for container, not for entire cluster or node. Just that's the use case when we want to have that just for that container. For example, within the container, we're running a few Docker containers or like app, and we want to monitor just that. This kind of use case I just created, so I want to show you that one. So yeah, let's start. To create CT container, I'll go to one of my nodes. I have that nodes full app and that full app as well. Sorry, that full app. On that one, I'm running monitoring for my cluster. So for all the nodes, also Prometheus and Grafana. Let's create container with Ubuntu. So to do that, I have to go to local disk where I can get the CT templates. I can't get CT templates on all the disks, as you can see, just on that one, probably as well. So go here, go to CT templates, go to templates, type here Ubuntu, and get one of those versions. I picked the latest one for today, and I downloaded it. So you go here, Ubuntu, and click download. So download will start. I have it here, so no worries. When we have the template on our disk, we can click create CT. We have to select node if you have more than one node on which one you want to install it. I'm going to choose PV node 1. Container ID, it will be added incrementally by Proxmox, but you can change the number. I'll leave it like it is, but you can't use numbers that already exist. It's not cool, not safe, not recommended. Host name, let's name it Grafana Prometheus test, just for testing because I'm gonna remove it later. Prometheus test, resource pool, not in here. Let's set that password for root user to that container. It's unprivileged container. We don't want to be privileged as root and do funny things for us. Let's click next. Template. We're choosing the disk where we downloaded the template before, and we're selecting the template that we want. I want to use that Ubuntu that I mentioned before. Next. Disk is the place from which we want to take storage for that for that image. I have here that 2 terabyte tank node, and I'll select the size for that image, for that container. Let it be like 16 gigabytes, not too big, not too small, because we need to contain that Ubuntu and of course our apps that we're going to install. I'm planning to drop there Java REST API Docker container just to check if I can access it later on and if my values in the dashboards are changing, if there's any load on that REST API. Probably I'm going to show you that one in a different video, not this one. In this one, we're just going to install the Prometheus and set up some Grafana dashboard. So yeah, let's do it. So yeah, what else? Nothing here. Next, CPU. Let's add 2 cores. That's it. Memory, 2 gigs and maybe 512 megabytes of swap. That's it. Here's DHCP. We can get the IP for containers from our local router or whatever you have in your network. If you have like a ISP network, internet provider, and your computer is connected through that via cable or Wi-Fi, it will assign the IP to that machine, but I don't want that. I want to leave it for IP6 because I'm not going to use it, but for IP4, I'm going to assign that IP. 072, sorry. And so that's my router IP, which is also my internet gateway. And I assigned it 72, not for any reason that might affect you. Just I know that IP is available on my router, and I can actually reserve that IP for the MAC of that VM, which is possible in the router. So I'm going to do that. But don't worry about that. That's not related. Just remember, you have to remember that IP, or later on, we can get that IP via command in our Ubuntu. Okay, so what else? Nothing here. Next. DNS, we don't have to change that one. Confirm. Yeah, start after created and finish. So container is ready. Let's go to that container. Yeah, that was that one, 106 Grafana Prometheus test. Let's go to console. Let's log in, root, and the password that we set before. Yes, we are here. Cool. It is always nice to run apt-get update. And then upgrade. Okay, it's ready. It's always nice to reboot. Let's log in again. Okay, now we are ready to start the proper setup. So we have to do 3 main steps. In the first step, we have to install a so-called node exporter. This one will export crucial metrics from our machines and expose that via API. And Prometheus will be able to grab those values from exporter. And at the end, we're going to install Grafana, and we'll connect Grafana with Prometheus, and we'll get the data from Prometheus in Grafana. So let's start with step 1, with getting the node exporter. I will paste in some commands. I'll leave link under the video somewhere to those commands because they are quite long. I don't want you to rewrite those commands, just copy and paste them. So let's get it first. So first we're going to download the node exporter. It's done. Then we're going to extract it and install with that command. It's done. Let's create a dedicated user. For that one, we don't want to use like root, so let's paste that code. Done. And now we have to create a system service for that one. So it will be stored in that directory, in that path, etc systemd system node exporter.service. Let's press enter. This one will open nano editor. You can use Vim. So with all the settings for that node exporter. Now Control O, enter, Control X, and yeah, that's done. So we have the file for the service. Now we have to run it. So daemon reload. Here we're going to enable the node exporter. So it's enabled. And now we're going to start it with that command here, node exporter. Now let's verify if this one actually is running. So as we can see, the status is running, so we are golden here. Cool. First step is done. So the second step is to download the Prometheus. It's done. Now we're going to extract it and install it with those commands. It's done. Now let's create directories and the user for Prometheus. Each line is different command, of course. Let's copy the Prometheus config files from Prometheus release to our machine. Let's check if the Prometheus config exists locally. Yeah, there is, but we want to replace the content for our node exporter to be a target. So let's do that now. Remove the existing config file, and I will add it again just by running nano with that path. So I'm inside. So let's paste in that content for the scraper, right? So yeah, let's Control O and Control X to close it. Now we have to create system service for that. So again, let's create config file for the service, right? So that config is like in the big picture. I will explain what is the service, when should it start, which user should it start, like here, and exactly how it should be launched. So exact start, and here we have the comments for that, right? So yeah, so let's save it, Control O, Control X, we're done. And what you have to do now is just to start Prometheus with a few commands. So first one, systemctl daemon reload. Second one will be actually enabling Prometheus. Let's enable it. Another one will start Prometheus. Sorry, paste in start. systemctl start Prometheus. And we're going to grab the status of the Prometheus. Should be green. Yeah, is running. So we are happy until now. So we can go to a browser and check if the Prometheus is running. Remember the IP that I said before in Ubuntu? That was 0.72 for the VM, and I'm going to use that one, and the port will be 9090. So yeah, that's the dashboard for Prometheus. Status, targets. We have targets, our machine. So yeah, it should be all right. So we can check if it's working. Let's here in the expression edit. Let's type something like node load 1. So the actual load of the node, how busy it is in every kind of minute. Let's click execute. We can't see anything now, but if you go to graph, we should see what's going on in the last 30 minutes, in last minute. So we see how busy our node was. There's a lot of metrics here, not just one, but we're not going to use them manually. We're going to use Grafana dashboards for that. So let's install Grafana. So for that, I'm going back to my VM, and let's grab the Grafana repository with that kind of long-ish command. It will take some time. So yeah, we have it. And the next step will be updating the repos. And now installing Grafana. It will also take some time. Looks like it's ready. Now we can start Grafana. So again, similar stack of commands, systemctls, enable Grafana server, starting Grafana, and the status, the most important for us now, looks like it's running. So we can go to a browser and check if it's working. Let's clear it here. Grafana by default runs at the port 3000. So I'm going to go to the same IP at my node. So 3000, and we see Grafana. So default username is admin and password is also admin. We have to change it after adding those. So yeah, I choose my own password that I'm probably going to forget very soon. Submit. So yeah, we are in Grafana dashboard. Nothing fancy is happening here. The most important bit for us will be dashboards. We have nothing there. We have to first add some connections to Prometheus, and then we're going to add dashboards. So let's do that. Let's go to connections. Let's expand it and add data source. Let's click it. Let's click add a data source. And the first one here is Prometheus, but probably we can search for it. So Prometheus. With the name, we can like keep Prometheus probably. And the address, the connection address, because we're using the same machine, will be localhost and port 9090. Remember when we used that port 9090 on that IP above here? But We can also, instead of localhost, we can pass that address. It's gonna work, but localhost is like better because it's within the same machine. If we're going to change IP, then we have to change that setting. So let's leave it localhost 1990. I'm not gonna change anything here. I'm gonna leave it as default. I didn't add any like fancy authentications. Yeah, nothing like that. Let's save and test it. So we are green. We can now explore the view or add some dashboards. Can test it here. Select metrics like node load one. Remember when we used node load one before? We can run it here as well. We can change the time. So in the last like 50 minutes, what was the load of my machine, how busy it was. But let's create some dashboards. First, we're going to add some dashboards manually. We can grab like CPUs, the memory, swap file, or how many reads and writes our physical disk have, something useful. And then I'll show you how to import the dashboards that are already done by other users. They are fabulous. I'm using them as well. They're quite busy, clunky. There's a lot of things happening there. Maybe you don't need all that stuff, so you can prepare your own dashboards. But yeah, let's jump into it and let's create our dashboard. So I click dashboard. Now let's click add visualization. Click Prometheus because we're going to get that data from Prometheus. Let's add our first dashboard here in that window. Let's go to metric. We can basically search for it manually, or we can type node underscore load, and we see load 1, load 5, and load 15. So let's use load 1. Let's click run queries. We can have one query, or we can have multiple queries. So not just one item will be shown on that plot. So let's click it. So here above we see how busy the system was in the last 6 hours. We can change that time in last 24 hours or in last 5 minutes. So we run few commands. A lot of things was happening, so it was going up and down, up and down. Okay, so let's have it. Let's save it, and let's name it, for example, system load 1M. We're going now is 1 minute, and let's press save dashboard here above. Let's give a name to the dashboard. So this is like let's name it main dashboard. We can pick where we want to save it. Let's save it in dashboards. Save. And now if we go to dashboards here on the left, when we click the dashboard, we see that we have it here, the load 1M. We can make it bigger, we can make it smaller. Let's keep it like that. Let's change that name because that name here, the legend, is a little bit ugly. So maybe edit. And here in the legend, let's select custom. And let's remove that. 1 minute. So as you can see, it will be already here. Save it, back to dashboard, and we can see here like the legend is a little bit better. Add new new dashboard. Let's create one for memory usage in percentage. So click here at the top, add visualization, pick that one. We're back again to that panel that we know, and here in the metric is not that simple anymore because we have to calculate a few things. So let's go here on the right to code, and here in metric browser, let's click here. So that code here, let me explain you that formula. A simple mathematics here. So that value here is available memory in a system in that VM at the moment. Not how much is totally available, how much it was assigned, but the free memory at the moment. Here is the total memory. in bytes that has been assigned for that VM. So we assigned, I think, 2 GB. So remember, all right? So that's the total, and here how much is used. So we have to divide this one by this one and multiply by 100 to get the percentage of the memory still available. So how many percent out of the total memory is available, and why 100 minus this one? Because Grafana doesn't show you how much memory is available, but how much is used. So from the 100%, we have to remove the amount of memory available, and that's how we're getting the percentage of the used memory, because we are interested with that. So let's run the query. So within the last 5 minutes, we have that kind of plot. In 1 hour, you see we use almost no memory, and suddenly we went up to like nearly 9.2%. Yeah, so quite kinky. So yeah, we have another panel ready. Let's give it a name. Memory usage in percent, memory usage in percent. And the same situation with legend, because here the legend is like not really pretty. So let's go here, let's select custom, and let's add that one. So it looks nice now. So again, save dashboard. And here, because we changed the time frame, so it will ask us every time we want to save also that change in the time range. So yes, we want changes. We can see the code here for that dashboard. It's good to like actually copy that code and keep it somewhere in like in repository, in case if you lose it, or the other developers will actually make some changes to the code. So you can have that somewhere in the repo, and you can have versioning of that. Yeah, so let's save it. Let's close that, and let's go back to dashboard from here now. We see that we have like a system load, and now we have memory usage. We can keep it like together. We can add row. So let's click on that icon here. Let's change the name. Let's name it crucial measures. And yeah, we can move those dashboards left and right. We can make it bigger and so on. Everything is green now because the system is happy with those values. It's just 10% of the usage, so it's not a lot. Let's add maybe another dashboard visualization again. Let's add now for CPU usage. CPU usage in percent. Again, code. Let's paste something here. Again, some calculations. This math looks a little bit more complicated, but actually isn't. So here we're taking that no CPU seconds total when the mode was idle. So there's different modes for CPUs. The idle is when CPU was actually doing totally nothing. There's a different modes like user system, IRQ, and so on. So we're taking the time when the CPU was idle and doing nothing in the period of time in the last minute. We're taking the percentage of that, right? So we're measuring how. Sorry, lost the track a little bit because somebody was knocking to my door. Actually, my cat came back from his fiancée. So yeah, I think I was talking about that formula here. So looks complicated, but it's not. So let me start again. So we take, no, we, but from Prometheus, we take the node CPU seconds total. We take the mode idle, so when CPU was actually doing nothing, not when it was busy, when it was actually not doing anything in that period of 1 minute. And it calculates the rate for it. The rate is going to change that value into time-based value. If that value will give 85, for example, 85%, so it will know that CPU was idle 85% of the time during that time window. And average is because it takes each core of the CPU is reporting that value, so it will take the average of all cores when the cores were not busy. And because we're not interested when the processor was not busy, but when it was busy, because we're calculating the usage percentage, we have to extract that value from 100%, right? That kind of idea. So yeah, let's run query. I hope it works. So yeah, it works. We see like the CPU was quite busy, 5 to 6. Was almost like how many percent? Like 42.5%. So yeah, exactly 42.4. Actually, there's a value at the end of it. So let's copy that and let's update the legend. It looks ugly. Looks ugly, but sometimes it's useful to have something like that when there's many things happening there. They dynamically added some values. We can use those curly braces to add some dynamic values there, but not in that case. Let's save it. Save. Let's go back to dashboard. The CPU usage is quite crucial. So let's add it here somewhere. Looks beautiful. Let's add it like that. This one here, this one here. So we have like system load, CPU usage, and memory usage. That's cool. Let's add maybe one more. I was talking before about CPU and that we have different cores, so maybe we can check how busy is each core in percentage. So let's name that panel CPU per core percentage. Is basically the same formula but without average. So we're going to have different values there. As you can see, I assigned 2 cores to that VM, so I see 2 different plots. But the legend is of course ugly, so let's improve it a little bit. Again, custom, and here let's change to CPU, because here in those curly brackets we see like CPU instance job mode. We can grab those and use in brackets here. So let's do like that: CPU core, CPU core 0, and CPU core 1. Yeah, so it's quite cool. Let's see maybe in the last 5 minutes. So yeah, the core 1 was actually more busy than core 0. It's quite cool. Let's save the dashboard. We changed the time range, so let's save it. Back to dashboard. We can create different section just for CPU, so let's do that now. Row. I'm gonna click here, CPU and CPU usage, CPU cores. Let's do like that. Right, so we have the basic. We can add more. Before I show you how to add the dashboards created by all the other users, let's go here to dashboard into refresh, and we can change that into like different values. So refresh every 5 seconds, or we can click here and refresh And we can also change that time range in the last 2 days, 6 months, or 1 year. I just started the node now, so there's no 6 months, but something like that. And every 5 seconds, we will be able to see like refresh of that dashboard. You see, it's changing every 5 seconds. So let me just wait a few seconds more. Yeah, it's moving. It's moving. Not much, but it's moving. So I stopped the video for a moment, and you can see like the dashboards are a little bit different because the time is changing. And now let's go and import some dashboards. So let's go to dashboard, save, why not? Time range, I don't mind, I can save those changes. And after going to dashboards, click on new to expand it and select import. Here we can paste in the JSON if we have JSON from somebody else, or we can add the dashboard ID. So there in that under that link, right? Different dashboard. We can choose which one we like, which one will actually fit to our machine. But I know the 1860 will be good for my node because I used that before. So let's click load. We can change some values here. We can change the node full dashboard. We can type the name for it. We can store it somewhere. And here is the unique ID for the dashboard. We have some information as well. Let's click import. Yeah, and that's about it. We have the dashboard now. As you can see, it's quite advanced. There's a lot of drop downs here, a lot of sections with different stuff. CPU, for example, memory. So a lot of things is happening here. Network, yeah, network traffic, for example, might be interesting, right? So how busy our app will be. So yeah, it's very interesting, but I want to show you that that stuff actually works. What I'm going to do, I'm going to stress my VM a little bit by running app named stress. First, we have to install that app sorry, on the machine. So that was that one, Grafana Prometheus test. And let's paste that code to install stress. Let's install it. And we can stress our machine in different ways. We can, for example, stress the CPU, make it busy, or we can make RAM busy, or both at the same time. And this is actually what we're going to do. So I'm going to close that one. You can go and search for dashboards that you like. I'm going to do it later on as well. But I'm going here to my node dashboard that I just imported. Or I can select the one that I've created before. Sorry, that was the one, main dashboard, quite poor. And let's go to that one. Let's change the values to like last 5 minutes, refresh. So we see like CPU is not very busy, it's 3.9%. RAM used 11%. Swap use is 0 because we're not using a lot of RAM, so the swap file hasn't been used. We have here different plots for CPU, for memory as well, for disk space, but we're going to be interested with CPU and memory and all those values here. Not all, but most of them. After we run the stress, I have the stress installed, but I did not run it yet. So let's go to VM and let's run the stress. So with that command, I'm using stress app CPU 2 because I have 2 cores, so I want to run 2 worker threads, which is going to make that thread 100% busy. VM worker 1, how many? 512 megabytes. It will keep that 512 megabytes in the memory. It will make the memory busy as well, and it will last for 60 seconds. Let's maybe change it to 75, and I will press enter. And after a few seconds, we will see some changes in our dashboards. So let's go to the dashboard that we created. Here on the second page, I have the dashboard for my node, entire node. As you can see, now the CPU and memory isn't that busy, right? The same here on the cluster. The CPU are quite chilled. Let's see if the command is running. It's running. So now, oh, there was a jump. CPU is 47% busy and is growing. Let's see here as well. Little movements here. Nothing significant. But now we see like CPU is 100% busy. That's what we want to see. System is loaded like 80-90%. RAM 80% is used. So yeah, no swap file yet. And here we saw like jump. This actually Grafana Prometheus test is the the container that we use to install Grafana and Prometheus, and we're making that container busy. So here you see like, oh, it's actually busy. It's like 50% now, 49.8 exactly. The only container that is busy now. CPUs are busy, right? Here as well, I think command stop, yeah, is not running anymore. So that's why we see now green. And maybe make the memory a little bit more busy. Hopefully that will work. Let's go to dashboards. You see the RAM used 95%, swap file 62%. Yeah, we're going to see some changes here as well. So that's my backup server. Prometheus. Here, let's go to our library. See some action here. But that one is totally busy. Memory. So yeah, that stuff is definitely working fine. I will stop the command. Refresh. I want those numbers to drop a little bit. Yeah, now they're becoming green. So yeah, that's everything for now. I hope you enjoyed watching that video. It was quite long. So yeah, thank you very much, and I'm encouraging you to watch my other videos. Thank you very much.